Beneath the calm blue waters of an African lake lies a hidden threat capable of affecting millions of people. Unlike most natural disasters, this danger is invisible, silent, and waiting beneath the surface. Scientists warn that one day, Lake Kivu could unleash a catastrophic event unlike anything most people have ever heard of. Lake Kivu stretches across the border of Rwanda and the Democratic Republic of the Congo, nestled in a valley of steep, volcanic slopes and green hills. Its surface glimmers at nearly 1,500 meters above sea level, surrounded by mountains that seem to cradle the water in quiet isolation. But this is no untouched wilderness. The shoreline is alive with cities and villages, Goma and Bukavu on the Congolese side, Gisenyi and Karongi in Rwanda, where markets bustle and fishing boats set out before dawn. More than 5 million people make their homes in the lake's basin, and for many, the water is a daily companion. It feeds families with its fish, ferries traders between towns, and irrigates fields that climb the hillsides. Children play at the water's edge, while adults depend on it for their livelihood. Yet, for all its beauty and promise, Lake Kivu holds a tension beneath its calm. The communities that thrive along its shores do so in the shadow of a threat that remains invisible, a reminder that even the most peaceful landscapes can hide extraordinary dangers. Beneath Lake Kivu's glassy surface, the water column hides a structure unlike almost any other on Earth. The lake is meromictic, meaning its layers do not mix from top to bottom. Instead, a permanent boundary forms at about 250 meters deep, a sharp divide known as the chemocline. Above this invisible line, the water is oxygen-rich and teeming with life. Below it, the world changes. The deep waters are cold, dense, and deprived of oxygen, creating a sealed chamber where gases can accumulate for centuries. In this hidden zone, the lake stores extraordinary volumes of dissolved carbon dioxide and methane. Scientific surveys estimate that around 300 billion cubic meters of carbon dioxide and 60 billion cubic meters of methane are trapped in the deep. These gases are not recent arrivals. Volcanic activity from nearby Nyiragongo and Nyamuragira has fed magmatic carbon dioxide into the lake for thousands of years. Microbes in the sediments use some of this carbon to produce methane, adding to the reservoir. The chemocline acts like a lid, locking the gas-rich waters safely below. Temperature and salinity differences keep this boundary stable, preventing the deep and surface layers from mixing under normal conditions. As a result, the gas concentrations below the chemocline have risen to levels rarely seen anywhere else. Measurements show that at depths of 350 meters and more, the water is close to saturation with both carbon dioxide and methane, an immense, invisible stockpile that is built up over millennia. The danger here is not obvious. From the shoreline, there are no signs of the vast gas reservoir lurking below. Yet the lake's deep structure is a scientific marvel and a source of unease. It is this hidden, ancient layering and the gases it holds that set Lake Kivu apart, making its calm surface a mask for one of nature's most extraordinary geological threats. A limnic eruption begins with a lake whose deep waters are loaded with invisible gas. In Lake Kivu, carbon dioxide and methane dissolve under immense pressure, held tight by the weight of hundreds of meters of water above. Over centuries, the gas accumulates until the deep water is nearly saturated, so close to the threshold that even a small change can set off a chain reaction. The process starts quietly. A disturbance, perhaps an underwater landslide, a seismic jolt, or a sudden shift in temperature, nudges the balance. At depth, the pressure is just enough to keep gas molecules locked in the water. But when this balance is upset, microscopic bubbles begin to form. Each bubble acts as a seed, gathering more gas as it grows. As these bubbles rise, the pressure drops, causing even more gas to escape from the surrounding water. This is where the runaway begins. The rising bubbles pull water upward, dragging more gas-laden liquid toward the surface. The deeper they come from, the more explosive the release. The process feeds itself. More bubbles mean more rising means more gas escaping, and the cycle accelerates with terrifying speed. When the plume breaks through to the surface, the result is not fire or explosion, but something far more insidious. A dense, cold cloud of carbon dioxide and methane spreads out across the land. Heavier than air, it hugs the ground, invisible and silent. In its path, oxygen is pushed away, leaving nothing to breathe. The lake's surface may look as calm as ever, but beneath that calm, the physics of a limnic eruption have turned the water into a silent engine of catastrophe. In August 1984, a quiet lake in western Cameroon became the site of a scientific awakening. Lake Methane, unremarkable to most, suddenly released a cloud of carbon dioxide that swept across the landscape. 37 people lost their lives within minutes, with no warning and no visible cause. 2 years later, a far larger disaster struck Lake Nyos, just 80 kilometers away. On the night of August 21st, 1986, Nyos expelled a massive volume of carbon dioxide. Estimates range from 100,000 to 300,000 tons. The gas cloud traveled silently through nearby valleys, suffocating 1,746 people and thousands of animals as it displaced the air they needed to breathe. These tragedies forced the world to recognize limnic eruptions as a real and deadly hazard. Scientists, once skeptical, now saw that deep lakes with trapped gas could overturn without warning. The events at Methane and Nyos became case studies. Proof that invisible dangers could devastate entire communities in a matter of hours. In the aftermath, attention turned to other lakes with similar conditions. Lake Kivu, with its gas reservoir nearly 2,000 times greater than Nyos, became the focus of urgent study. The scale of Kivu's threat is not a matter of speculation. History has already written the warning. Lake Kivu sits atop the western branch of the East African Rift, a place where the ground itself is restless and change is constant. Here, the African continent is slowly pulling apart, stretching the crust and opening deep fractures that reach far beneath the lakebed. These rift movements create pathways for magma to rise and for gases to seep into the water, shaping the basin over thousands of years. The region is marked by active volcanoes, Nyiragongo and Nyamuragira, whose eruptions and underground activity keep the setting unstable. Earthquakes ripple through the basin, sometimes strong enough to shake the land and lake together. Volcanic tremors, underwater landslides, and sudden shifts along hidden faults all have the power to disturb the deep layers of water. Even in recent years, seismic swarms and dike intrusions have been recorded beneath the lake, each one a reminder that the forces below are never truly at rest. These geological pressures act as invisible hands, always capable of nudging the delicate balance that keeps Lake Kivu's gas reservoir trapped. In this landscape, The hazard is not only what lies beneath the water, but the restless earth itself, a system where the next disturbance could come without warning. Engineers have turned to the lake's depths with a careful strategy: controlled methane extraction. By drawing gas-laden water from deep below the chemocline and separating the methane, they are gradually reducing the amount of gas trapped in the lake. This process is not a simple fix, but a deliberate effort to lower the risk of sudden gas release. Each step is measured to avoid disturbing the delicate balance that keeps the gas contained. Extraction rates are closely monitored and pressure is managed so the layers of water remain stable. In this way, the methane burden is slowly eased, one calculated move at a time. Kivu began generating electricity from Lake Kivu's methane in 2016, turning a looming hazard into a daily resource. The plant draws gas-rich water from the deep, separates the methane, and uses it to power engines that feed Rwanda's national grid. Shama Power, another major project on the lake, is also extracting methane for energy, supplying power to communities along the shoreline. These facilities do more than reduce the risk of a catastrophic gas release. They provide a stable source of electricity in a region where energy is often scarce. Here, hazard management and energy supply are inseparable, with science and engineering working side by side. Surveillance of Lake Kivu relies on a web of sensors, data loggers, and cross-border protocols that never truly sleep. The Lake Kivu Monitoring Program, established in 2005, brings together Rwandan and Congolese scientists to track gas concentrations, water pressure, and seismic activity in real time. Alerts from gas pressure transducers and seismic stations feed directly to both governments, triggering emergency plans if readings cross set thresholds. Annual coordination meetings, joint evacuation drills, and shared datasets form the backbone of this fragile safety net. Yet, even with these efforts, no one can predict exactly when or how the deep layers might be disturbed. The hazard is managed, not removed. Vigilance, not certainty, is the rule. For millions living along the shore, security depends on constant oversight and cooperation, an uneasy balance between human ingenuity and the unpredictable forces beneath the surface. Even now, Lake Kivu's tranquil waters veil forces powerful enough to reshape lives and landscapes in an instant. As scientists race to manage these hidden gases, the lake is a living reminder. Nature's greatest threats often lie silent, waiting, unseen, just beneath the surface. What else are we missing?